ROBOCON 2020 involved a game of rugby sevens between a try robot and a pass robot. For the passing process, multiple mechanisms were tested, such as a pneumatic based catapult claw mechanism, a spring based slingshot mechanism, and counter rotating drums mechanism. The drum mechanism with a pickup claw was selected as the final passing mechanism due to its speed, simplicity, and reliability. For the kicking mechanism, we tested a pneumatic based kicking leg, but as it generated quite a bit of jerk and inherently violated one of the game rules, we selected a DC motor based kicking leg as the final kicking mechanism. It was simple and effective. We even added a counterweight to the rear end of the kicking leg to balance out the mass and reduce the jerk generated on rotation. The try mechanism was a simple DC motor based claw which could grab the try ball independent of its orientation and rotate 180 degrees to place the ball in the try spot. Lasers were placed on the PR for the team member as a reference for position of the tee and kickball in the kicking zone 3. Optimal curved paths were calculated for fast traversal of the TR through the obstacles. Our robust and modular electronic system comprised of microcontrollers and microprocessors serving as a platform for our sensors and our navigation algorithm.